So welcome guys, welcome to MOL Concept Lecture number 10 and eCareerPoint-English medium channel. Oh, how are you? Naveen is there. So hello Naveen, how have you been? Have you revised all the lectures, previous lectures? Yes Naveen? Are the previous concepts clear? Okay, I can see a lot of guys today. Yes. So I would love if you can share this session, if you can, tell this to your friends, especially to the ones who have problem with the Hindi language, so that they can also get the benefit of quality education. Yes, and do like the channel, do share this channel. It will mean a lot to us. Yes. So as you guys know the drill, what is first of all the very important part, that is in the last lecture, if you guys remember, we were talking about what? We were talking about mass relationships. So is the last concept clear? The mass relationship, they are clear? Yes. Hi Naveen. So I hope Naveen, you are thorough with what? You are thorough with mass relationships. So today we will talk about mass volume relationship. This is the second part of the series, which will help us to understand the stoichiometry and the limiting reagent with somewhat more clarity. Yes? Okay. Yes, it's clear to Naveen. Okay, so let's proceed. So in the mass volume relationship, whenever we talk about mass volume relationship, what this is basically regarding the mass. The mass can be of a component, let's say it can be of solid, let's say it can be of liquid, let's say it can be of gases. So mass is a property which can be of all the phases. Yes. So if I have, let's say I have solid, let's say I have a liquid component, let's say I have gaseous component. So mass can be defined of all the three phases of matter. Yes. Whereas whenever we talk about volume, and especially in chemistry, when we talk about volume, we have to look for the volume of what? We calculate the volume of liquids first of all, and secondly we calculate volume of gases. So in case of volume, we generally tend to ignore the volume of solids. Yes. Okay, so here's good evening doctor. Yes Ashwin, we are trying to our best to complete this syllabus as soon as possible. The target is to complete these topics before your next NEET examination. Yes, don't worry. The starting chapter, this is the foundation chapter, whereby this is like, yes, I told you, this is the foundation chapter. If this chapter is understood, we are taking it slowly because this chapter generally it confuses the student. So the target is make sure this chapter is understood, then the further incoming chapters you won't be facing any problem. Yes Ashwin? Yeah, we will take a class on the questions part, where we will discuss about the special questions which are asked in your NEET examinations, as well as I will take one for the JEE as well. Okay. So regarding the mass volume relationship, what will happen in these type of questions? You will be given mass of, let's say, solid or liquid or gas, or you will be given the volume of some, let's say, liquid or gas. So either two of these will be given. So one from this side and one from this side. So how to solve questions based on mass volume relationship? It's something that we need to learn. Sure Ashwin? Surely. So let's proceed. That is, let's understand this with the help of a question. So look at this question. First, I will tell you how to solve this question. I will solve this by two methods. Again, the first method will be the important, that is the conceptual part using mole concept, and second method will be a shortcut which you can use in your examination, especially the competition. Yes. Oh, good evening Sudeshna, how are you? Yes. Mohammed, for the mock test, I will make, let's say I will make some slides of the test. I will make sure you download the app and I will attach the slides there. So you can solve this paper, and in day or two I will give you the answers as well. So you can self-analyze the test And otherwise there is a concept of Menti quizzes, whereby you can solve questions in live classes, so you can do that as well. Yes, Ashwin, let's see within 4 to 5 lectures more, because this chapter will be done in 2 parts. First it will be mole part, second will be equivalent concept. Okay, so how to solve this type of question? Again, they have given us an equation. In these type of questions, there would be the mass of one component is given. Again, what they have given, they are saying you have been provided with 46 grams of sodium. So let's write the equation. So what do we have? We have sodium plus half oxygen, and this is giving us sodium monoxide, let's say. So this is my net equation. Yes. In this equation, what they have given us is, they have given us the mass of sodium. So what we have been provided? We are provided that you have 46 grams of this component. And what they are asking? They are asking, calculate the volume of oxygen at STP. So we need volume of oxygen at STP. So this is the question, complete question. Yes. Now how to solve this type of questions? First, let's try it by method number 1. So what is my method 1? It is just the basic approach using mole concept. Now what I will do in these type of questions will be, every time when I have to look at these type of questions where mass and volumes are given, do one thing, try to convert this question to moles. Yes, try to make sure you are calculating the moles using the volumes and using the masses. Amazing. Even I am very well. Thank you, Sudeshna. So I hope you have revised the previous lectures and make sure you understand what we are learning right now. Yes. Now what I will do, whenever these type of questions are there, I will try to convert everything to number of moles. Now what I will say? I will say 2 moles. So what are the number of moles of sodium? So number of moles of sodium, how many moles of sodium do we have? So moles of sodium will be given mass upon molar mass. Yes. So given mass by molar mass. This is the moles of sodium. What is given mass? It is 46. Molar mass is 23. So we have 2 moles of sodium. So I converted the left part, that is mass part, to moles. Next what I will do? I will calculate now I will relate these moles of sodium with moles of oxygen. What I will do? I will say 2 moles sodium, it is reacting with half moles oxygen. Yes. So 2 moles sodium is reacting with half moles sodium. So how many moles of sodium do we have? We have exactly 2 moles. So 2 moles of sodium, they are reacting with half moles oxygen. So moles of oxygen, what is the moles of oxygen reacted? It is 1/2. And how to calculate volume from moles? We simply use the formula, that is volume of oxygen at STP. It would be equal to number of moles times 22.4. So this is coming out as 1/2 times 22.4, and this value is 11.2 liters. So this is the volume of oxygen produced at STP. Yes, Sudeshna, your answer was right. Okay, so there is a question, reaction. How are these reactions formed? How do they form the reaction? Basically at this moment, because this is the first chapter of physical, at this instant we don't know about the reactions. The reactions will be provided to you guys. Yes, but eventually when, yes Anil, eventually when we will be thorough with all the chapters, that is this reaction is of S block. In S block you will learn about this reaction. Then in P block you will learn about other reactions as well. Similarly for D and F block. So whole in organic chemistry is about reactions. Which compound will react with which other compound and what will they form? This is all about inorganic chemistry, which will come in the eventual chapters. So right now you don't need to worry about these reactions. Just worry about how to calculate. The reactions will be given to you guys. Okay? Sure, Anil. So let's proceed. Now what this was method number 1. In method number 2, it is just a shortcut which you can use for competitive examinations. Look at how I am solving this. So what is my method number 2? It is my shortcut, and this is something which you have to use for you will use this for what? You will use this in your competitive examinations. So what was my equation? First of all, write the equation. That is Na, 2Na solid plus half oxygen. Yes, gaseous, it is giving me Na2O solid. So this was my reaction. What I will do is, I will simply say, how many moles of sodium do I have? Simply relate the moles. That is 2 moles sodium. Now 2 moles sodium means what is the mass of sodium? It is simply 46 grams. So 46 grams sodium I have. And in case of oxygen, I will deal about volume. So how many moles of oxygen do I have? I have half moles oxygen, which means I have 11.2 liters oxygen. Now simply what I know from unitary method is, that means 46 grams sodium, it is reacting with 11.2 liters oxygen. Yes, this is what I can infer from this reaction. Now what they were asking? They were asking about 46 grams, yes. So this is my final answer. So it is just a direct application of, you will simply relate the mass with the volume. Whenever you find these type of questions, try to find the volume of gas and try to find mass of the solid. You will directly get the answer. Now, is this concept clear? If this concept is clear, you guys have to solve the next question based on this very concept. So solve this question. You guys have to solve this question. That is, magnesium right now, it is reacting with nitrogen and forming magnesium nitride. Now what they are saying? They are saying 11.2 liters of nitrogen it is getting consumed with at STP. Find the number of moles of magnesium nitride formed. So they have right now what they are saying, you have 11.2 liters of nitrogen is consumed. Yes, so if 11.2 liters nitrogen is consumed, some magnesium nitride would be formed. They are asking about what is the mass of magnesium nitride formed. So try this by any method. You like the first method, you can use the first method. You like the second method, you can use the second method. So try to solve this question. You have to find the mass of magnesium nitride formed. First, if I have to help you, I will say try to solve it by moles. And in case you are not comfortable with moles, you can simply use the method number 2. Okay, so we are having a question from Mohammed. How half moles oxygen? Mohammed, because it was given in the equation, right? Look at this half mole equation. Whatever I am writing here, this is all from the balanced chemical equation. So I wrote the balanced chemical equation. And right now, I am trying to get what data I have been provided with. So I have been provided 2 mole sodium is reacting with half mole oxygen. So 2 mole sodium means 46 grams sodium and half mole oxygen means 11.2 liters oxygen. So simply I related the data. Yes, Sudeshna even has the answer. Let's see if it's right or wrong. Calculate the mass of magnesium nitride formed. Okay, so she has the answer. She is saying 50 grams. So what about others? Anil, tell me, what about you? Muhammad, Naveen? What do you think should be the answer to this question? I am waiting for you guys. Yes. Yes, Sudeshna, exactly. This is smart work method. You just save a lot of time because in your examinations, especially in NEET and JEE mains, what we are dealing with, we have to solve a lot of questions in very less time. So when it's time, again, it's a race between you and the time. So when the time is a priority, all you have to look how you can save those crucial seconds. So if I can save at least 30 seconds from 1 minute, it means I have saved 50% of the time. for one question. You can use this time in any, let's say, a question of physics, or for JEE students, let's say a question of maths, which takes a lot of time, because solving, those big calculations, sometimes you need that extra seconds. Yes, so okay, so Anil has got the answer 50. So let's see. Again, I will do this by method number 2, that is the smart method. In case anyone wants me to do this by mole, I can do it. Yes. So what is the second method? Simply write the equation. So equation is this. Yes. Now what I will say what we have to relate. We have to relate nitrogen with magnesium nitride. Yes. So nitrogen, I have how much? I have 1 mole nitrogen. So 1 mole nitrogen, it goes with 1 mole magnesium nitride. Yes, but I have to deal with volume of nitrogen, and I have to deal with moles of mass of magnesium nitride. So what is the moles of nitrogen? That is, what is the volume of nitrogen? 1 mole gas always occupy 22.4 liters at STP. So it goes with, what is the mass of this compound? I think it comes out as 100 grams. So it goes with 100 grams magnesium nitride. That is, this is the molar mass of magnesium nitride. Okay. So this is the data which we can infer from the balanced chemical equation. Yes. Now look at what they were asking. They were asking me 11.2 liters of nitrogen. So 22.4 liters nitrogen goes with 100. Then 11.2 liters nitrogen, it will go with what? It will go with half of this, that is 50 grams magnesium nitride. So this is my final answer. Is this clear? So, but in previous classes, moles are given in the question. Yes, even right now, moles were given. What is this? Look at this data. 11.2 liters of nitrogen. So if they have given 11.2 liters of nitrogen, you guys know this, right? Number of moles, it is given volume upon molar volume. Now what is the given volume? It is 11.2 upon what is molar volume? It is 22.4. So what is the answer? It is 0.5 moles. So even in this specific question, Mohammed, they have given us the number of moles, not directly but via volume. So is this clear to you? Tell me, Mohammed. In this part, not directly moles are given, they are given in the form of volume. So if this thing is clear to you, we will solve the next question. Yes. So let's see. Next is this. Now this is a very interesting question, because here we have to deal with limiting reagent as well. Yes. So this question involves limiting reagent as well as what? As well as mass volume relationship. So this is a good question. You can expect these type of questions in your tough exams. Yes. So try to solve this question. Let's see how many of you can solve this. Yes, I can see. Amazing response. So what should be the answer? Mohammed, Hemraj, Sudeshna, sorry, Anil, Naveen, what should be the answer to this question? So what should be the answer? First of all, tell me, what is the limiting reagent? It will matter more. What is the limiting reagent in this case? Is it calcium hydroxide or is it CO2? What is the limiting reagent? What do you think about the limiting reagent? Is it calcium hydroxide or CO2? Okay, so let me solve this. That is, in this question, this is the equation given. So calcium hydroxide, it is reacting with carbon dioxide and it is forming calcium carbonate plus water. Yes, so this is what they have provided us. Look at this. In calcium hydroxide, if I look, what they have given me, this is 7.4 grams. Yes, and this they have given us as 11.2 liters. And they are asking what is the mass of calcium carbonate formed. So they are asking me mass of calcium carbonate. Yes, now this is the final question. So how to solve this type of question? What to do now? First find the limiting reagent. Yes, I have to find the limiting reagent. Hi Rishi, came a little late today. Sudeshna has given us the answer, 12.2 grams. Okay, even the Sudeshna is saying calcium hydroxide is the limiting reagent, whereas Anil is saying calcium, CO2 is the limiting reagent. So there is a clash between Sudeshna and Anil. So let's see who will win. Okay, so first what we do, we have to find the limiting reagent. What I will suggest is go for the moles. So if I find the number of moles of calcium hydroxide, so it will come out as given mass upon molar mass. So this value is coming out as 7.4 divided by molar mass is 74, which is coming out as 0.1 moles. Yes, and in case of carbon CO2, so number of moles of CO2, it will be given volume upon molar volume. So this is coming out as 11.2 upon molar volume is 22.4. So this value is coming out as 0.5 moles CO2. So you have 0.1 moles calcium hydroxide, whereas you have 0.5 moles of CO2. That is amount of moles of CO2. They are more in number. Whereas if you look at the equation suggests us that 1 mole calcium, this calcium hydroxide, it reacts with 1 mole CO2. So 1 is going with 1. So if I had 0.1 moles calcium hydroxide, then it would react with 0.1 moles carbon dioxide. But how many moles of carbon dioxide do we have? We have 0.5 moles. So limiting reagent in this case is calcium hydroxide. Yes. So Sudeshna, you were right. Calcium hydroxide is the limiting reagent. So everything will proceed as per the calcium hydroxide part. So what we will do? We will relate this calcium hydroxide with this calcium carbonate. So what this equation suggests us that 1 mole calcium hydroxide, it goes with 1 mole CO2, this 1 mole CaCO3. Yes, so this goes with 1 mole CaCO3. So how many moles of calcium hydroxide do we have? We have 0.1 moles of calcium hydroxide. So what to do? So we have 0.1 moles calcium hydroxide. So this basically means it goes with 0.1 mole calcium carbonate. So we have moles of calcium carbonate produced, that is moles of calcium carbonate. They are coming out as 0.1, but we have to find the mass. So mass of calcium carbonate, it is coming out as 0.1 into 100, which is answer is 10 grams. Yes, so Sudeshna, I think you miscalculated the molar mass of calcium carbonate. Yes, Sudeshna, that was your mistake, because I think otherwise you identified the limiting reagent, it was right. Even you related the value of moles as well. But the final calculation, I think there is something wrong with the molar mass. Okay, So this is all about mass volume relationship. Is this thing clear to everyone? Right now we will dealing with the volume of gases. Yes. So the mass volume relationship, in this the volume component was coming from the gases. So what if the volume, it comes from what? It comes from liquid. So this is type 2 questions, whereas the volume of component is coming from the liquid part. So let's see, that is mass volume of, here the volume is coming of SOL, means solution. So right now the volume is of solution. So how to solve this type of question again? Again, whenever we are solving about any questions of mole concept, the default method to solve this type of questions is to go via moles. So go via moles, make sure you are looking for the number of moles, relate the moles and get the answer. Now I will solve this question. Yes. What does this equation suggest us? They are saying there is an equation, that is H2SO4. This is an acid-base neutralization reaction. It is reacting with the base, forming sodium sulfate and water. Yes, this is my final equation. What they suggest is you have 0.4 grams of this. So you have 0.4 grams NaOH, and they are saying it is reacting with VML of 0.01 molar H2SO4. So this is the data provided in the question. For complete reaction, calculate V. Yes, this is the question. So what we will do in these type of question is, we will simply relate the moles. Yes, we can simply say 1 mole H2, let's say, or we can simply say as the moles of H2SO4 reacted by moles of NaOH reacted. So they are coming out as how much? The ratio is, look at this, 1:2. So this is the ratio. Now how to calculate number of moles of H2SO4? We can say number of moles of H2SO4 is molarity times volume. So this is molarity of H2SO4 times volume of H2SO4. But this volume would be in liters divided by number of moles of sodium hydroxide. It is, here the mass is given. So from mass I can say what are the number of moles. So number of moles of NaOH, it would be equal to given mass by molar mass. So what is the given mass? It is 0.4 divided by molar mass is 40. So this value is coming out as 0.01. So we have 0.01 moles of sodium hydroxide. So put it here, it is coming out as 0.01. Yes, so relate it, that is the molarity was, what was the value of molarity? It was 0.01. So I am replacing this by 0.01. So 0.01. So this and this gets cancelled. Yes, it was 0.01, right? Yes, so it gets cancelled. What is the volume? Volume of H2SO4 in liters, it's coming out as half liter. That is volume of H2SO4. It is coming out as half liters. So what is the volume of H2SO4 in milliliters they were asking? So it would be 500 ml. And this is my answer. Is this thing clear? Is this question clear to everyone? If yes, you guys have to solve the next question. Any doubt till now? This is how you will solve questions based on mass volume relationship, where the volume is of a solution component. Here the volume is of liquid component. Yes. So everything is clear to everyone? Okay. So let's proceed towards the next question. Based on this very concept, you have to do the next part, next question. Again, look, do what? Write the equation, relate the moles, find the answer. So let's solve this question then. Again, a similar type of question. An equation is given. Yes, try to relate the moles. So let's see how many of us can find the answer. Yes, I am seeing. So let's see. Mass to gram. Yes, Anil. Rishi, hi, I am here with you. Don't worry. So, what do you think? What is the answer coming? Sudeshna, Rishi, Anil, Mohammed, what do you think is the answer? Yes. Again, what is the trick behind this? You just have to look at the moles. So just try to relate the moles, you will get the answer. So what is the moles of barium hydroxide? What is the mole of HCl? Just relate them. Yes. So what is my first step? First, write down the equation. So what is my equation? The equation is barium hydroxide plus 2 moles HCl. It is giving me barium chloride plus 2 water. Yes, this is my equation. So what I will do in this case? Yes, I will say the moles of barium hydroxide which have been reacted upon the moles of HCl which they have reacted. So both are reacted, they are in the ratio 1:2. So this is my step number 1. Then look at what they have given. For barium hydroxide they have given us molarity and volume, whereas for HCl they are asking about mass. So what I will do is, I will simply say this is molarity times volume upon number of moles in terms of mass. It is given mass. Let's leave it till here. Let's say this is moles of HCl. So this is value is coming out as 1/2. What is molarity? Molarity is 0.1, and what is volume in liter? This volume should be in liter. It is again 0.1 upon moles of HCl. It is coming out as 0.0. So from here, the moles of HCl, they are coming out as 0.02. But we have to find the mass. So what is mass? Mass is number of moles of HCl times molar mass. So this is coming out as 0.02 times molar mass is 36.5. So this is coming out as 0.73 grams. Is this thing clear to everyone? Tell me. Is this thing clear? Yes, amazing. So this is how we will solve mass volume type of questions where the volume is of any component, any solution. Yes, so let's proceed. Next is volume relationship. Now we have delved into the directions of volume relationship. So whenever we are talking about volume relationship, what we know is it can be of two types. Yes, it can be of gas type, that is both the gases are involved. So this is the volume of gas relating with volume of other gas, or it can be volume of solutions. That is right now the relationship between two solutions. Now when it is about gas relationship, then we study a branch of chemistry which is called eudiometry. Whereas when it's about solution, that is volume of solutions, then what we call this as volumetric analysis. So this is volumetric analysis, and other one is eudiometry. So we will learn about both of these because the questions have been asked on this particular concept again and again, and this is how you do your experiments in your lab. So this is the experimental part. Whenever you, right now I think you guys are not having the access to the labs, but once it is open, you guys will eventually do, when you enter the chemistry lab, you will do these type of experiments. They are called titrations. So you will learn about these titrations in detail. Yes. So let's proceed. Any problem till now? Okay. So what I will do is, first let's say we study solution-solution relationship. Let's start with volumetric analysis first. Let's complete it and then we will proceed to eudiometry. Okay. So what is volumetric analysis? So when you enter your chemistry lab, whenever you will enter, I don't know when will that day come, but in case it comes soon. So what you will say is, there is this type of setup, whereby this thing, let's call it as beaker or flask, let's say beaker, and this is the instrument called burette. Now this instrument is very, very important. I don't know if you guys are able to see, there's reading on both of them. Yes, even there's reading for calculating the volume of any component which is present in this beaker, and even for the burette. So in beaker, what we generally take is, we take an acid. So let's say I took 100 ml HCl in this. How do I come to know this is 100 ml? Because I can measure this. Yes, there is measurement units present on this flask or beaker. I can say it's 100 ml. So this is what I took. In these type of questions, especially in titrations, in volumetric analysis, we call it a titration because there is a reaction between my acid and I am adding some base to it. How will I add the base? I will add the base with the help of burette. Now what is the burette? If you can see here, there is a tap on the lower part of the burette. Yes. So what we can do is, we can open this tap. So once we open this tap, the base which is present here, let's call it as, let's say we have NaOH. So base will eventually enter this beaker. Now whatever amount of base that has entered this beaker, that volume can be calculated with the help of these measurement units. Yes. So this is how you come to know what is the volume of NaOH that you entered in this beaker. Yes. So let's say this volume was 50 ml, and one thing which we must understand, which we should know regarding this experiment is the concentration, that is the molarity of NaOH. This is something which we already know. Okay. So concentration of NaOH is known to us. So let's say this is 0.1 molar. So we have 0.1 molar NaOH, whereas the concentration of HCl, let's call it as M, this is not known. So M is something which we have to find, and this is the whole purpose of the experiment. That is, you have to calculate the value of M. So concentration of any component present in this beaker, it is not known. So what we are doing, we are setting up an experiment between acid and base. So what does the acid and base do? They basically react to form salt and water. So what is the reaction between them? That is, my acid HCl will react with my base, that is sodium hydroxide, and it will give me sodium chloride and water. Yes. Now my acid is reacting with base. Now what we do? From this equation, I understand that is moles of HCl, if 1 mole HCl is reacting, it is reacting with 1 mole sodium hydroxide. That is, always the moles of acid would be equal to moles of base. For what? For that part whenever this happens, that is, the moles of acid, they are equal to the moles of base consumed. That is, if I took, let's say 10 ml HCl and I am adding 10 moles HCl and I am adding 10 moles NaOH from the burette, then at that point whole NaOH will react with whole HCl. That is, my acid will react with my base, and what we will get? We will get a salt and water. This specific point It is called equivalence point. So what is equivalence point? When my whole acid reacts with my base. So there can be a question, so how will we know if the NaOH, if the base has reacted completely with acid? So for that we use something called indicators, about which we will learn in our ionic equilibrium chapter. But at this instant we can know. There is the mechanism by which we can know when to stop this burette. Yes, because molarities and volume is in our control. So how to calculate? Simply open the tap, see how many mLs of this base is added, just do the calculations. Okay, yes. So what is my equivalence point? It is that point where the moles of acid is equal to the moles of base. So once acid and base are consumed, what we are left with? At equivalence point we will just have my salt in water. So this is also another indicator of equivalence point, where only salt and water are left, no base or acid should be there. So this is all clear. So they have written, when the acid is completely consumed by base, it is called equivalence point, and at the equivalence point neither the acid nor the base would be in excess, that is only salt in water would remain. Yes. Now if in case this happens, what we will do? We can simply say, like I know, what was my equation? So HCl was reacting with NaOH and it was forming NaCl plus water. So what we can say is moles of HCl, they are equal to moles of NaOH, and from here what I can say, moles of HCl, molarity of HCl times volume of HCl is equal to molarity of NaOH times volume of NaOH. Or otherwise we can say, also say as M1V1 is equal to M2V2. Yes, so this is how we can solve these type of questions. Yes, but this is not the formula which we have to learn. We just have to derive this from the equation itself. So what's the method to solve this type of questions? Make sure, so let's calculate the value, right? So what was my molarity and volume? So my molarity was 0.50, 0.1 and 100. Yes. So this is 50, this is 0.1 and this is 100. So times m. So what's the answer? 0.05. So from here the molarity of HCl, it is coming out as 50 into 1 by 10 divided by 100. Yes. So 0.05. This is my final answer. So this is how you will solve these type of questions. Is this thing clear? If this concept is clear, again, the thing is, we call this complete setup, this experiment, it is called titration. So this setup, this experimentation, this is called titration, whereby what is the language used? They are saying whatever you have to calculate, let's say I have to calculate the strength of HCl. So they will say HCl is titrated against NaOH, that is the base. So whatever you have provided with NaOH, we know all about NaOH, that is we know the molarity, we know the volume. So we will say, in case I have to find the molarity of HCl, in case I have to find the yes, so in case I have to find the molarity of HCl, I will simply say, that is I am doing the experiment and I am calculating at equivalence point, that is moles of acid and moles of base, they are equal and they are getting consumed completely. At that instant, in terms of chemistry, when you are going to the lab and you are doing the experiment, you will simply say to the lab assistant that I want to titrate HCl with NaOH. So it means you have to calculate the concentration of HCl and you know the concentration of NaOH, because volumes are something which we will eventually look at the this setup and we can calculate. Yes, good evening Hemant, how are you? Yes, so what we will do right now, we will see how to solve. Yes sir, I took the mass of carbon wrong. Okay, sure. So this is called titration. Again they have mentioned, in titration the strength of one solution In this case, in our case, the strength of HCl can be determined from the concentration of another solution, that is NaOH. Yes, we didn't know the molarity of HCl, but we could calculate the molarity using the molarity of NaOH. Yes, and this the language uses HCl is titrated with NaOH. So this is how we will solve these type of questions. Is this thing clear? Yes. Okay. So in the next class, we will solve the questions based on this very concept. Till now, did you face any problem? So any problem faced till now, you can ask me. Otherwise, yes, it's clear to everyone. So guys, we will meet in the next session where we will do questions based on titrations. So there are three type of titration questions which we will look at. First, the normal titrations, then there is a concept of double titration, then there is a concept of back titrations. So three type of titration we will do in the next class. Yes, and we will do lots and lots of numericals so that this concept is crystal clear. Okay, so with this, let's end the session. In case you enjoy, do like, yes, and do tell me in the comments, sir, yes, we love your lectures. You guys, it will really, boost up my confidence as well. It will make me feel like, yes, I am doing something for the society, for you guys. So anyway, thank you guys for joining me this late. This means a lot. So take care of your health, take care of your family, and take care of chemistry, because that's what matters till now. Thank you, Ji. Thank you. Bye-bye.